Okay, so kind of talk a little bit about caching today. When I was thinking about ideas for this conference, I was like, what can I do that's, for a lightning talk that's fairly short, fairly concise. Still showed a little bit of code and showed kind of the process of using a library that's a Java library. And so what is Cache2K? Well, it's an in-memory caching library that runs in the JVM. There's a whole bunch of other libraries that do this stuff. Some of them you might like over another. But I particularly like Cache2K, and I've been using it in production for a while. So it's kind of what I wanted to do because I actually went through the process of using it in Java and then using it in Kotlin. It's open source, so I'm not trying to sell you something here. If you want to give me money, that's fine. I'll take some cash. But it is just an open source library. It's very small. It's just a couple of dependencies. Really easy to use. Pretty straightforward. Does its job. Does it well. Does it very fast. It's low overhead, and it has some nice advanced features, which I won't get into in this talk because we don't have enough time for that, but it does have some cool things like it'll do refresh ahead. So if you have a cache that expires at midnight, it will automatically refresh the data in that cache just prior to expiring. So the thread or whatever that you're using is never impacted by that. So first thing I'm going to do this in two quick sections. First one is just talking about it standalone, just by itself, which you could do if you were using Android, if you're just using a plain old Java app. There are integrations to other things, like you can integrate it with a lot of different Hibernate and other things. I'm just going to do Spring after this, though. So starting out, if you're just doing the standalone version, just a couple dependencies that you need, either in Gradle or Maven if you happen to use Maven. I'm not going to spend too much time on that. As far as creating the cache, it does this weird anonymous inline class thing. So even in Java, I think this is always a little weird when you create an anonymous inline class. So this is a little bit of Kotlin. Who here has used Kotlin? I know you guys have. Okay, so some of you have, maybe some of you have not. So some of this might look a little bit odd, but this is pretty much the same rough structure as you have in Java, except you're using val instead of var if you use newer Java, or the old Java way of doing things where you'd say cache equals new cache. So we don't have to do that in Kotlin. It's a little bit more concise than that. But basically what we're doing here is we're building a cache to store routes to airlines. Now caches tend to operate a lot like a hash map, so you have a key and you have a value. I'm using the example that the creator of Cache2K uses in his code, because I redid all of his examples in Kotlin, which I'll give you a link on that later in case you're curious. But what he does is he has a route, like New York to San Francisco, an airline route, or San Francisco to Los Angeles, or LaGuardia to Chicago, and then he has in the cache a preferred airline. So the idea here is for New York to San Francisco, your preferred airline might be Delta Airlines. So that's the cache I'm modeling here, and I'll show you more examples of this in a second. We give it a name, we do an expire after write, so it does have the ability to automatically expire cache entries after a given time. I'm showing in this example just a fixed time limit, but another cool thing is they have expiry policies, so you can actually say, I don't have any fixed time, but when something is put in, you can inspect what you put in and change the expiry based on the data that you put into the cache, which is kind of cool, rather than just having it always expire at a certain time. There's other expiry things. There's like fixed expiry, like I said, midnight, not in 2 minutes, but at midnight, this is all going to expire. And there's also the ability to have a fixed number of entries in the cache. So in this case, it's 100, but you could say no more than 5 entries, no more than 1,000, no more than 10,000. And then it's got a really nice algorithm that's kind of like least recently used, but it's better than that. I won't go into details. That picks and chooses which ones it keeps in the cache. All of that is configurable. You can turn all that off. You could have the cache be unlimited and have no expiration. Okay, so we've created one. Now how do we use it? I'm using 2 data classes here. So again, this is for those that are Kotlin people. This will look perfectly normal. For those of you in Java, you're missing the new. So in Java, you would do probably old style Java. You would do capital route equals new route. In Kotlin, we don't do all that stuff. We eliminate all that nonsense, and we just say val route equals route. So I'm creating a route, and I'm creating an airline, and then I'm just showing a couple simple examples of how you use the cache. You can put something in the cache, you can peek and see what's currently in the cache, and you can remove it. Anybody that's done this before has done this pattern a million times, where once you have these things, you end up writing this logic that's like, okay, I want to do this service lookup on the route. And so you end up writing this code that's like, okay, peek if it's in the cache. If it is in the cache, return that. Else, do the actual lookup. Get the result back from the lookup. If the result is not equal to null, then put it in the cache and return it. And that's boring, and we don't want to do that. So Cache2K gives you the ability to attach a loader, which I'm showing here. This is basically a callback, and it will do all of that stuff I just said for you. You just tell it how to load something, and it takes care of all the details, which is kind of nice. I'm showing the actual callback here. I'm doing it as kind of a method reference, but that could also be a lambda in Kotlin. And down here, this is just like your business logic implementation. So that's about it for that. Oh, once you do this, I don't have this in the slide, but you will do a get operation, not a peek, because a peek just looks at what's already in the cache. A get operation will actually invoke the loader if it's not there. So. Okay, for the second part, checking time, we're looking pretty good. We're going to talk a little bit about Spring Boot and Cache2K. So everything I've just shown you is just sort of like this quick standalone API, but you can also integrate this with Spring using the Spring Boot starter cache. Again, their dependencies are the same. This is the same stuff I showed you in the first slide. There's a little library that does the interface between the Spring Boot cache and the actual Spring Boot starter cache. This last piece is just a standard Spring caching layer. So you can use that with all sorts of caching things that are not Cache2K. So this is just adapting to the standard way for Spring to do caching. All right. Now, I'm going to go over this again. How do we configure it? I had a similar example in the standalone. Here, we're going to do a bean that is part of a class. Up at the top, there's an at configuration, which is a standard Spring, like this is a configuration class. And you also have to annotate it with at enable caching, which, believe me, is very easy to forget, and then you wonder why absolutely nothing works. Some people, if you're already doing Spring, you'll already have a configuration class, so you just add this method in and add the enable caching. In this case, I'm just creating a brand new class to do this. So there's a little bit of, boilerplatey stuff that I don't spend too much time thinking about, but when I first did this, getting the syntax just right between the way it's done in Java and the way it's done in Cache2K took me way too long, like 45 minutes, which is why I'm doing this slide, to save you all the time of having to go through this thing. Normally, if you're a Java person, you can cut your Java, copy your Java in IntelliJ, paste it, and boom, it becomes Kotlin. This completely breaks that and won't work, because it doesn't know how to handle the specific syntax. But so you have a bean here called Cache Manager. That is the bean that's going to be invoked by Spring to create the caches. And then it uses this Spring Cache2K Manager, and it adds caches, and notice it says caches, not cache. I'm only showing one here, but normally you're going to have a list of 10, 15, 20, 30 caches that you want to add. Other than that, you'll notice that this is pretty much the same as what you saw in the first slide, because you're actually using the same instance that you were using in the first slide with configuration with Cache2K builder. So you're still going to set entry capacity, your expiration. You can set up expiration policies. There's a bunch of other kind of nice parameters in here, but other than where the code goes, the insides of it are pretty much the same. Okay, how do we use it? So, of course, Spring loves to have annotations. So in the previous example, I showed the loader, which was a really nice way to kind of take some code that you already have that does something and tell Cache2K about it. In Spring, you can actually take an existing service and just annotate it with @cacheable. And this, all of that code right there, is actually just your normal business logic. It doesn't have any Spring stuff, it doesn't have any caching stuff, it doesn't use any peaks, it doesn't do anything like that. So all we're doing to enable caching is just to add that one annotation. And the annotation has a couple parameters. The first one is the name of the cache. Okay, that's pretty easy, right? The second one is called key. And when you first look at this, you're like, what is this key thing? It has to know because, as I said earlier, a cache has to have a key and a value. The result of this is going to be put in the cache, so we know what the value is. But we don't know what the key is. And what Cache2K, and well, what Spring and Cache2K actually both do by default is they effectively don't do this, but they effectively just take whatever the parameters to the method are, and that becomes the key. And it concatenates those together. If one of the parameters is a class, it does a toString on it and concatenates those together. And it all kind of works, but normally that's not what you want. You want to be able to tell it what your key is. So in this example here, I've intentionally broken that by passing in something called log output. Why would you pass a parameter called log output? I don't know. But it's something that's not needed in the key, only the ID is, which is why key equals hash ID says use the ID as the key. The second example is to evict something from the cache. In other words, delete that entry from the cache. Here, interestingly, you don't need to implement anything because there is no business logic. I mean, I guess you could have business logic if you wanted to delete something or whatever, but normally when I use it, I just have it empty. And there's a cache evict. Again, you're passing in the name of the cache. And again, you're using the Spring expression language. Here, I just did this to show a different example, which is I'm actually going inside of the parameter person and getting the ID out of it. So it's nice, it's really flexible. You can kind of integrate it with like the business logic you already have. So how does this work? So we're going to do controller service 101. Controller calls person lookup service and asks for something and it returns a value. Okay. That's how it works without caching. How does it work with caching? With caching, what Spring actually does is instead of calling the actual person lookup service, it does a proxy class around it that handles all of the caching stuff for you. So when person controller asks to have a person lookup service injected, it doesn't get this actual instance, it gets the proxy. So it kind of tricks you out and gives you, the proxy that does all the stuff that like the loader did or the lookup stuff did. And then when you call it, you're actually calling the proxy, and the proxy here is going to be looking up, does it exist in the cache? No, it doesn't. It's going to pass it on down to the actual service, and I'm not showing it, but it's actually going to return it to the caching proxy. It's going to add it to the cache and return it. There's a reason why I'm explaining this, which I'll get to. Second time around, if you do it, it just skips that lookup entirely, which is great. This is what we want. This is why we want to use caching. Caching is partly for performance, but there are some other really good reasons to use caching. Let's say you don't care about performance at all. And the application I use, this is funny, but the reason I use caching is almost not at all for performance, because our requests take about 35 milliseconds to respond. If I made that 4 times faster, would anyone notice? Absolutely not, because the response goes over the internet. The internet takes about 80 milliseconds if you're going across the country, so a half a millisecond is not going to make a difference. But what it does make a huge difference on is the load on all the servers, transaction costs, because we use Amazon Web Services. So those are all things that, like if you're doing database lookups or you're doing Dynamo lookups, those are all transaction costs that can add up. So having the cache is there for performance, but it's also there for scalability, reliability, a bunch of other things. Okay, one gotcha, which when you first use this is going to seem weird. Here's a service that has, that cacheable annotation I have. Okay, great. We did that all works fine. here's another method in that service that makes use of that find person by ID. And if you write this and you code it up and you're like, this is going to be great, I'm going to get all this caching performance, and you actually test it, it doesn't cache anything. There is no speed up. It still does a lookup for every single thing. You're like, why doesn't this work at all? The proxy. So remember that the way the caching works is only if you use the proxy can you get the cache. And I'm calling it this. So I'm not calling the proxy, I am calling the actual class. So there are other workarounds for this, by the way, but I'm just going to show one, a quick one. And that is kind of a hack, but you can have person lookup service inject itself and use that person lookup service rather than calling this. And Spring is going to then inject not person lookup service, but the proxy, and thus everything will work fine. Is it the most elegant solution? No. But, and there are other ways to do this. You can structure your code differently so that you're not doing this sort of cache lookup inside the service to itself. But that is the easiest way to fix the problem, I guess. So, that concludes my talk. A bunch of contact information here. I do have full samples. I wrote about 18 times this amount of code in order to prepare for this presentation. And then as I did the presentation, it got squashed down. But I do have full code samples on GitHub of both the standalone and the Spring examples and the Cache2K documentation. Any questions? Yes?
When you said cache expired, I didn't understand at the beginning.
Yes. What was the question?
When you're calling through that service to get data and then automatically cache that by calling the provider, can you say how long it lives before it
Yeah.
refresh?
So you can do it like in the example I showed in both of them, either with Spring or without. You can set an expire after array.
So once that's set, that's just consistent. You can't have it dynamically decide when to
Yes.
provide that.
That's a good question. So there are, I kind of covered on this, but there are sort of 3 ways of doing that, maybe 4. You could have no expiry whatsoever, right? It just lives forever. You know, obviously the limits on the entry capacity would eventually remove things from the cache, but you can live forever. You can do this, which is 30 minutes in the future. You can have strict expiry, you know, noon, you can say at noon, or based on some other condition. You can actually add an expiry policy, which when you put something in the cache, it calls that expiry policy method, and their expiry policy tells, you know, passes you what's being put in. So it'll pass you a copy of the person object, and then you can look inside the person object and be like, okay, this is a full-time employee, I'm going to cache them for 30 minutes. Or it's a part-time employee, I'm going to cache them for 5 minutes. So there's all sorts of options and flexibility around that. So. Cool.
All right. Thanks once again to Dave.